4. All right, guys, to get started, we're going to look at question number 8 from 1.4. So looking at this one here from 1.4, we're given 2 points for swimming pool volume and time. Now the first thing we need to do is find the slope. So we're going to have 300 minus 180 over 3 minus 5. Now at this point here we can simplify. 300 minus 180 is going to be 120. 3 minus 5 is negative 2. So our slope is negative 60. So I'm going to use the top point 3, 300. So we'll plug 300 in for y, negative 60 in for our slope, and 3 in for the x value. Now we can distribute the negative 60, which would give us negative 60x plus 180. At this point here, we can add 300 to both sides, telling us y is equal to negative 60x plus 480. And to interpret the slope, the pool's volume is decreasing at a rate of 60 cubic feet per hour. Any other questions on this here? Yes, cubic feet. All right, we're going to look at the other problem, problem number 4 from 1.5. Now we're given 3 equations. Now, we're going to use the top equation given to us in the problem, which is our x plus 4y minus 6z equals negative 1. And I'm just going to choose to eliminate x first. So on the equation on the left, we're going to multiply everything by 2, telling us 2x plus 8y minus 12z equals negative 2. Now at this point here, to get the x's to cancel, we will subtract. 2x minus 2x would be 0. Negative y minus 8y is negative 9y. Negative 2z minus negative 12z, the negative and negative make a plus. The plus 14z is equal to negative 7 minus negative 2 is going to give us negative 5. Now, since the eliminator equation and 4y minus 6z, the x's are already the same, we don't have to do anything to it. So we can put it just underneath. And this time, unlike the other, we're going to add the 2 equations because the signs are opposite. Negative x plus x would be 0. 2y plus 4y would give us 6y. Negative 4z minus 6z is going to be negative 10z. And 5 plus negative 1 is going to be 4. Now at this point here, we need to pick one of the other two variables to eliminate out. So looking between these two, we can pick between y and x. I'm going to go on and just do y. Eliminate y out next. Now to do this, we're going to have to multiply both equations by something to get them to be the same. Now we can go through the process of figuring out what is going to be the first number that I can turn both 6 and 9 into, or I can just multiply the equation on the right by 6 on both sides, or the equation on the left by 6 on both sides, and the equation on the right by 9 to get them to be the same. Now for the one on the left, when we do this distributing of 6, 6 times 9 is going to be negative 54y plus 14 times 6 is going to be plus 84z is equal to 30. When we do the same thing on the other side, 9 times 6y is going to be 54y minus 9 times 10z is going to be 90z. Yes. Yes, thank you. Because I was about to throw everything off. Mm-hmm. Questions on this here? Now at this point here, we're going to put one on top of the other. So I'm just going to rewrite the other underneath here. And because our signs for y are opposite, we're going to add, because negative 54y plus 54y is 0. 84z plus negative 90z is going to be negative 6z. Negative 30 plus 36 is 6. Divide by negative 6, so z is equal to negative 1. Now at this point here, we can pick one of the two equations above to solve for y. I'm going to take the negative 6y minus 10 times z, but we replace z with negative 1. Well, negative 10 times negative 1 is going to be positive 10. Minus 10 on both sides, so 6y is equal to and lastly, we need to solve for x. So I'm going to take the x plus 4y minus 6z equals negative 1. So we'd have x plus 4 times negative 1 minus 6 times negative 1 is equal to negative 1. So our 4 times negative 1 would be negative 4. Negative 6 times negative 1 is going to be positive 6. Negative 4 plus 6 is going to be plus 2. I need a little more screen. So our point is negative 3, negative 1, negative 1. So, yes. Yes. Because I'm not going to ask you to rewrite them out on a separate sheet of paper just with the answers. If you have all the answers there, circle it, make sure it's obvious what the final answer is. I'll take it all. Because for the most part, I can work through it and see what's what. Because I've looked at it long enough and seen enough of it, I can normally figure it out. If not, I'll just ask and kind of get some reference points and go from there. Because again, the main way I grade this is I look at the answer first and then go backward from there.
Oh, you back to it?
Yep. Because percentages are, if you got the right answer, you did the right work. Does that make sense?
Yeah.
So if you got the wrong answer, I'll work back through it to try to see where the misstep occurred and go from there. A matrix is a movie, but that's not what we're going to be talking about today. Is a rectangular, let's focus up here, is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and n columns is represented by this here. Rows will always go first, columns is second. Rows is our up and down. So we go down, how many numbers? That's the rows. And then columns is going left to right. And we state the dimensions rows by columns. Now we also have something called an augmented matrix for a system of equations. For example, the system below can be represented as an augmented matrix. So we can take a system of equations, and we're just taking the numbers in front of them with their signs and setting them up as a matrix. So if we took this system, 5x plus 3y minus 2z equals 1, x plus 2y plus 3z equals negative 1, and 3x minus 4y plus z equals 10, and we take the coefficients, the numbers in front of the variables with their signs, we can make an augmented matrix. Now this augmented matrix dimensions are, well, we have 3 rows and 4 columns, so we call this a 3 by 4. Now, we're going to look at these here. We're going to write an augmented matrix, state the dimensions first. Now, when we write an augmented matrix, we do need to make sure the variables are lined up. And if you don't have a graphing calculator, you're going to need one. We're going to be using those. Either. All right. Now, one of the biggest things with an augmented matrix is the variables have to line up. And the normal way we write this is x first, y second. Also, with an augmented matrix, anything that does not have a variable, our constant terms, need to be on the other side of the equal sign. So if we look at these two equations, our second one, x plus 3y equals 12, is fine as it is. However, the first equation, y minus 2x equals 1, is in the wrong order. The variables are on the correct side. Our constant terms, the numbers without a variable, are on the correct side. So all I need to do is reorder this. I need to move the 2x to the front. And since we moved it to the front, it takes its sign with it. So it's going to be negative 2x. The y is positive, so we have plus y is equal to 1. So we've just rewritten the equation. Questions on this here? Now to write the augmented matrix, we draw a big O brace. If the batteries are dead, we're rewriting it so that x is first and y is second. You can go on and grab a different one. That's fine. We'll leave it as is until they need to actually be changed. Completely dead? Okay, go on and grab a different one. Those are definitely not dead because we need x first, y second. So x is -2, so we move it to the front. Then y. Because when we write these, we want the variables in order x, y, and if we have a third one, z. We want them in the same pattern. So since x is first, we really want x to be first, y second, z third. So when we write the augmented matrix, we're taking the numbers from it. So for the first one, the number in front of x is, number in front of y is 1. It would be positive, so we just write 1. And our last one is 1. So the first one, we have -2, 1, 1. How about the next one? 1, 3, 12. We get 1 from the x, 3 from the y, and it's equal to 12. We want the x's to be first, then the y's, and if we have z, it goes third. Now, the dimensions, we have 2 rows and, yes, so it's a 2 by 3. There is cases where we will plug a 0 in, but that is if a variable is missing. Now, if we look at this here, is there a variable z in either equation? We don't include it. If one of the equations has z in it, it has to be included in all 3. But if it's not written, its number is 0. Does that make sense? So if we had one of the equations, the bottom one had x, y, z, the top one only had x, y, that means the value for z in the top equation would be 0. But the only time we do that is if that variable is included in at least one of the equations and not in the others. Questions on this here? Let's look at the next one. So we want to write the augmented matrix and state the dimensions. If we look at these two equations, the top one we need to rewrite because we need 4x plus 3y is equal to 13. We need x first, y second. Is the second equation in the correct setup? Okay. So let's write our augmented matrix. What would be the numbers going across the first row? Second one. -1, 5. We've got to take the signs with it. So if it has a minus in front of it, it's negative. We take the negative. And the dimensions are 2 by 3. Questions on this here? So you ready for the next one? So, write an augmented matrix for this system, then state the dimensions. So for the top one, well, right, z's on the wrong side, yes? Now I can't just move it over. We have to do what? Because it's on the wrong side of the equal sign, yes? So if I'm moving something across an equal sign, we would have to add it to both sides. So we still have 3x, guys, minus 4y plus 2z is equal to 7. Because unlike the last ones where it was in the wrong order, x, y were on the same side of the equal sign. Since it's on the other side of the equal sign, we do have to add it to both sides to get it to be the same. So, okay. So I'm going to put a line through that to remind myself I'm not using that one anymore. We're using the one over on the right, or on the left. The middle equation, x is first, y is second. We don't have a z, but we do have a number on the other side, yes? It's set up in the correct order. And the last one, we have x first, y second, z third, equals number. So the rest of the equations are set up in the correct order. So let's create our augmented matrix. So going across the top, -4, 2, 7. because we're working off this one here. 3, negative 4, 2, 7. Let's do the next one. 9, 3, 0, 3. Because the other two did have a z, this one needs a value for z, which is 0 because it's not there. And the last one. 2, 4, negative 1, 2. So, dimensions. Rows go first. How many rows do we have? How many columns? And that is it. Questions on this here? We good with this here so far? Let's look at this one. Are any of the equations in the wrong order? No, because top one, XYZ number, XYZ number, XYZ number. All of them are in the correct order. So we can go on and state the dimensions or write the system. So going across the top, it would be? Next one. 2, 1, 4, 2. Last one. And this is a? Okay. Questions on any of this here? Do we feel comfortable doing these here? Okay. We're going to move on to the next part. Solving systems of equations using technology. Now this here, many tools each have matrix features that you can use to solve a system of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, is given to us here. Now the solution is this here for the system. Now when we put the numbers in, we put x first, y second, z third. So what the first one is telling us is that I have 1 times x plus 0 times y plus 0 times z is equal to negative 1.4. But really, what do we have? We have x is equal to negative 1.4. The second one, 0x plus y plus 0z is equal to y is 5.2. And the last one, 0x plus 0y plus z equals z is 16. So our solution is this right here, x, y, z. Okay. Now there's some steps to doing it, and they are provided in the note sheets here. 1, write the augmented linear system. Write the augmented matrix. Enter the augmented matrix, use reduced row echelon form, and interpret the answer. So we're going to look at this here. Now, it's nice because it did give us the equations in the correct form. We have x, y, z. So the first thing we want to do is write the augmented matrix. So going across the top, we have what? 1, 1, 1, 2. The next one is going to be 2, 3, 1, 3. And last one, 1, negative 1, negative 2, negative 6. Questions on how we wrote this augmented matrix? And the dimensions for this are 3 by 4. I know there's a little more written down for yours. I did include that in there so that you have it. Grab the graphing calculator. First thing we're going to do I'm going to clear all this out underneath. We're going to do second matrix. And I do have key press history down at the bottom. X to the negative 1. We have this screen, yes? X, and so second, blue button, X, negative 1, X to the negative 1. And we all get a screen that looks similar to this here. You might have different numbers where I have 1 by 1, 2 by 2, 2 by 2, 3 by 4. But you do have a screen that looks similar to this here, yes? Those, at least you've got A through I in brackets, yes? That's fine. What we want to do is go over to edit. We're going to hit the right arrow twice. So at the top of the screen, edit should have a black box around it, yes? What this lets us do is edit what is going to be inside the matrix, what is going to have it for those values. Hit enter because we're going to plug this into A. Now our dimensions of our matrix were what? A 3 by 4. So, yeah, each number that you type in, you can hit enter and it'll move to the next spot for you.
Oh, X negative 1.
So when you hit second, all the terms or stuff above the buttons in blue, that's what it's going to take in. Questions on any of this so far? Now it might look a little different just because the model type, but now we're going to type our matrix in. Because across the top row is what? 1, 1, 1, 2, yes? So I'm going to hit 1, enter, 1, enter, 1, enter, 2. Do the same thing for the second one. I hit enter, so it goes to the next one. And we have 2, 3, 1. It's still there, it's just not on the screen. Yeah. It's still there, it'll move over to it. One, enter 1, enter 1, enter 2. So it's there, it's just sitting off to the side. Yeah. All right, do the second row. 2, 3, 1, 3. And if you get both of those, 1, negative 1, negative 2. We're typing the whole thing in. We want that entire augmented matrix typed in. Once you've got that typed in, second mode. So right next to it, second mode. Yes, second mode. We're going back to the home screen. Did we get here? We got it typed in, yes? So that's step 2. A part of the steps is to enter the augmented matrix. We did that. What we're going to do next is go back, second matrix. But this time we're going to go to math. We're not going to edit. We're going to math. We want it to do a calculation. And in that list, down below, there is one of them called RREF, Reduced Row Epsilon Form. So we're going to have to scroll down. So B, RREF. Once you find it, hit enter. And on your front screen, you should have RREF listed. See? And in parentheses. We have this here, yes? Now, we need this to be applied to the matrix we just put into it, matrix A. So we're going to do second matrix one more time. Now, the first list that keeps getting pulled up is naming it. It's going to tell us these are ones we can actually do stuff with. Since we put it into number 1, I have it highlighted next to it. We hit enter. If I hit enter, it'll pull up matrix A. So we have RREF parentheses matrix A. Go on and hit enter. Again, go on and hit enter one more time. And let's see what we get. Does it look like this here?
Yeah.
Top to bottom, X, Y, Z. So the solution for this matrix is -1, 1, 2. The solution for this system, -1, 1, 2. So back over here, the solution for this here is -1, 1, 2. That's it. The calculator just solved it. Yeah. Yeah. Yeah, we are going to do it again. That is it. -1, 1, 2. Yeah. So I'm going to write on the screen. So guys, let's focus up here for a second. What I'm going to write next is going to be kind of what this is telling us. If you do go back and watch it, if you're watching the video, you're not going to see any of this. Because for some reason, when I write in this mode over the top of the screen, it doesn't show up in the video. But what we're saying is that this is X, this is Y, this is Z. So the top one's telling me that I have 1X plus 0Y plus 0Z is equal to -1. But 0Y is just 0. It's gone. 0Z. So I'm just saying X is, the same thing's true for the middle. We get Y is 1, and the last one Z is 2. So the solution for this is -1, 1, 2. And we have our answer. Now let's look at the next one. So this here, again, all this here is the stepped out version of it. This is another kind of just picture form of step by step. Yeah, kind of what the screen should look like at the end of each step. Now, let's look at this next one. First thing we need to do is write the augmented matrix. So across the top for the first equation, we have 2 from 2x. We have 3 from 3y, -1 from z, and 15. The next one we have questions on how we wrote the augmented matrix.
Gets the equation or whatever.
Yeah, there are matrix operations that they use to get it in that form. So the next thing we need to do, yes. Yes. So to input it, I'm going to go second matrix, go over to edit, and I'm just going to edit matrix A. We don't have to have them as separate ones since we're replacing the equation. Enter. It is still a 3 by 4. Now going across the top, we have 2, 3, -1, 15, 3, -9, 9, -12, 4, -3, -1, 19. After I type each number in, I hit enter because enter will move it to the next spot. Questions? Yes. You use the arrows. So which one did you miss?
I don't know anymore because I gave me my.
Well, 2, 3.
I used only 1 instead of -1, so I was trying to...
Yeah, because I can go back over
Yeah,
here.
and then just
So if I say 1,
Okay.
yeah, I did that earlier. I had to
Yep.
figure it out. I did third dot.
yeah, because you can use the arrows to go back and forth. Questions on this here? So we good with getting the matrix typed in? Yes? Okay. Now, we're going to go second mode, second quit. Second mode, second quit. We want to quit out of that matrix so we don't put anything else in there. Now, second matrix, we need REF. So we go 1 over to math. You can go up or down to get there. Because if I go up, it goes to the bottom of the list first. And we hit enter. Second matrix A, enter. 5, 1, -2. That is the solution. Yes, because we changed what matrix A was, so it applied it to the new one.
But I mean, like, it didn't do what I entered. It changed it to 5.
Right. Because what it's doing is it's getting row epsilon form is this diagonal of 1s. That's the form that it's getting it into. And it works out, if it's in this diagonal of 1s, the solution is the last column. Something a little different. Yeah, it's going to be the last problem because we ran out of time. So 3 by 4. 2 to 3, -1, 15. 3, -9, 9, -12, 4, -3, -1, 19. Yeah. Now what's interesting is just those two changes ended up giving you the same solution as the one before, which the odds of that actually occurring are actually very, very small. Because one small change normally makes a big difference on the answer. But it's interesting that that worked out that way. Yeah, give me 1 second.